So there's this guy on YouTube who literally just learned something and then he does a video telling people about it. It's called Computer Programming University. Anyway, so what is multi-threading versus multi-processing? So I'm building a messaging server, a financial messaging server. That's one of the projects that we were working on as a team. And I ran into an issue where I needed to basically have two things or two parts of the application run concurrently at the same time. And that led me to the rabbit hole of multi-threading. So multi-threading, basically, you have to think of it as a subset of a process. So you have a single process, and that process can spawn multiple threads. And in doing so, allows for a sort of enhancement in terms of performance, in terms of performance of how the application runs. And I'll get deeper into to what that is all about. Now, multiprocessing is where you're actually using multiple processors, as the name suggests. So, with a multiple processor system, you have multiple physical processors that can run multiple processes at the same time, right? So I have one process here, I have another process here. This process can be run by one processor, and this one can be run by another processor. Now, with a multi-threading model, you can actually have a single processor, and that single processor can execute multiple threads at the same time. So, again, you have a single process, and that process can have multiple threads. Now, in practice, what does that mean? So, typically, any program that you're using is going to be a multi-threaded program. So you're running an application, like, for example, I'm doing this live stream using the YouTube app, right? So clearly there's multiple threads going on. So in the upper left-hand corner, there's a timer indicating this video is 2.24 seconds long so far. So there must be a timer thread that is not only calculating the time, it's keeping track of time, but also it is displaying it at that particular location with that font and the black background. These are all functions of, and that might be an important phone call. 1 second, I apologize. Hello?
Hey, Carlisle, how are you? Pankaj from PD.
Hey, I'm doing pretty good. How you doing?
So Wednesday at noon or by 2 o'clock, I'll have those approvals. At that point, I will send you some documents to fill out and apply online. I'll send you a link.
Okay, perfect.
Till Wednesday, that's what's going on. I'm just waiting for this guy's approval at this point. That is why I haven't sent you the documents and everything else. I want to be 100% sure that I have all approvals before I send you everything.
Sure. And are you going to be emailing or sending via the
I'll email everything. Everything's done via email.
digital? Okay, just want to make sure. All right, thank you for the update.
Thank you.
All right, thank you. Take care. All right, bye. Well, making deals while I'm doing live streams. That is a pretty big deal with a major bank. So that's happening in a few days. So pending my approval of the deal, of course, because they're not the only bank that is making a deal. But anyway, so you have this. So again, I lost my chain of thought. So I'm running this YouTube app, right? There's a separate thread that is handling the timer, right? There's another thread that's handling the video component of, like, I can see myself on my screen, right? So there's just other things going on, right? There's filters on the bottom and things like that. But those are two threads right there, right? A thread for the video, for the webcam, showing so I can see myself. A timer thread in the upper corner. So let's eliminate multi-threading and see how that looks. So without multi-threading, I can either look at the timer or I can see myself on the screen. Can't do both, right? I have a single threaded process that's only able to do one thing at a time. Either I'm seeing myself or I'm seeing the timer, not both. Now, in theory, you could bounce back and forth. I could see the time, see the video, see the time, see the video. And that's an interesting concept because there is the concept of multitasking where you it's sort of like smoke and mirrors in a way where you're it's I'll call it fake fake multi fake fake multi-threading, fake multi-processing. So imagine I can only push a total of 100 pounds, right? That's the maximum weight. And I have two boxes, 100 pounds each, right? So I'm single threaded in the fact that I can only push 100 pounds, and this is 200 pounds, right? So I have to push one or the other, right? I can't do both. Now with a multiprocessor model, right, I would have the capability of actually pushing 200 pounds. So I could have 100 pounds in this hand, another 100 pounds in this hand, and I could just push those boxes down. That's the beauty of multiprocessor systems. And that's what makes them more efficient as well because, well, more efficient in terms of how much work can be done, right? Pushing two boxes at the same time is great. However, that is more resource intensive compared to multi-threading. So with multitasking, what I can do is I can trick you into thinking I can actually push 200 pounds down at the same time, but I really can't. What I do is I do this concept of switching where I will push this 100 pounds, push that 100 pounds, push this 100 pounds, and if I keep going back and forth from box to box, you're not really paying attention, perhaps. I can give you the perception that I'm pushing two boxes at the same time and going down, but I'm not really, right? I'm just going back and forth really quickly. So that's a sort of computer trickery. But that is the essence of multi-threading. So you're running multiple threads at the same time. Now another thing to consider is with multi-processing, it's more resource intensive in terms of you're like a process has its own memory, has its own physical resource, right? Like there's a data file that the process is using or something like that. Maybe you build something that parses a file, right? So that file is opened, right, in Python, right? You open the file in read mode or whatever, and then you're now accessing that file. That's happening, right? But the thing about it is, I am getting old and I lose my chain of thought sometimes. What was I saying? The beauty of live streaming. Thanks for the like. The beauty of live streaming. What was I saying? That is amazing to be going somewhere and then completely have it vanish just like that. I guess I was talking about the efficiency, right? So with multi-threading, you're sharing the same resources, right? You have a single process that is running multiple threads, right? So I guess getting back to this using the YouTube app, right? I'm sure this YouTube app runs or consists of multiple processes. There's a lot of things going on here. I doubt it's a single process and everything is just a thread, right? There might be a process that handles the webcam from my perspective in terms of what I'm seeing on my screen. There may be another process that handles the pushing of my camera's image to you guys, all right? There may be another process that handles sound and so on and so forth. But the idea is with multi-threading, I can have a single process that handles all of the video related functions, right? Whether it's me seeing myself or it's you seeing me because the camera signal being converted, transmitted via the stream, right? That could be a single process running multiple threads. One thread is what I'm seeing, the other thread is what you're seeing, right? And there can be another process that handles the stream itself, right? The compression of the data so it can be transmitted via the internet to YouTube servers and then therefore to your computers, right? So that in itself could be another process. So there's a streaming process. There's a video process. There is a GUI process, perhaps. There's a filter process because I can click down here and see just the fact that I can do this. This is the beauty of multi-threading. The fact that I can do this. I'm in the middle of a live stream. This is running. I can see an active video image. I got the timer up there and I can click here and now I can do different filters. So see that? So there's probably a filter process, right? And that filter process has multiple threads. One thread generates the menu. I can see on the bottom it says Slate, it says Dawn, right? And when I click on these, that thread draws a white box to let me know what I've selected, for example, right? So that could be a thread in itself, like a menu thread, right? Then there is an actual filter thread in terms of the actual application of the filter, right? So now the image is being changed, right? And that's another thread, right? There's another thread that has, let's say there's a thread that has a bunch of functions, right? Each function contains the information required to trigger the filter. So let's say if this was Python, I would import filter module, right? And then within the various functions for each filter, right? I could call whatever filter. So for the black and white, so there'll be like a function called black and white, and in that black and white function, it would basically call the black and white filter from the filter library, right? For example. But again, the ability to have all these things running at the same time, sharing the same resources. So let's say getting back to the filter. Now the filter potentially, I lack the experience level. I've never developed an app like this. So I don't know how many processes perhaps would be required to run a simple menu like this. It might be multiple, could be a single. I'm leaning towards thinking it'll be multiple. It seems like there's a lot of things going on. I just don't see it being a single process. But let's just say it was a single process. If it was a single process, then that process could hold on to it could basically share resources. It has a certain amount of memory allocated. Maybe there's files that are required for it to run properly, and whatever it's needed, it can share it with all of the different threads. Because once again, single process, multiple threads. With a multiprocessor system, you have to expend unique resources for each process, right? Every time you spawn a process, you're grabbing resources, so it's going to be more memory intensive. Multi-threading is much more efficient, and the ideal scenario is a multi-threaded application running on a multiple processor system. Right. That's the ideal scenario, because with that scenario, on top of the ability to have a single process running multiple threads simultaneously, you also have multiple processors. So you can just grow and grow, where you have one processor that's running 6 concurrent processes at the same time. Each of those 6 processes actually have maybe 12 threads running. That's a lot of stuff going on at the same time. And then because you have another processor, you can duplicate that, right? You can have a second processor doing the exact same amount of work as that other one. And since they're 2 physical processors, these can be done in parallel. But again, the multiprocessing side of that is actually inefficient. but it's the combining of multi-threading versus multiprocessing that allows it to achieve some really amazing results. And that's why we can do the amazing things we can do today, like virtual reality, for example, which is very resource intensive, which definitely takes advantage of multiple processors and for sure multiple threads. So anyway, so that is the essence of what multi-threading is. The ability to design something that can do multiple things at the same time and also achieve a much higher level of performance because of that efficiency of not being stuck on one thing at the same time, because of the efficiency of, again, the shared resource model, right, with multi-threading versus multiprocessing, where it's more resource intensive by itself. So I guess what I would extrapolate from that is that if I were to choose between a multi-threaded application running on a single processor system versus a multiprocessor system running a series of single-threaded processes, I mean, of course, the devil is in the details, right? How many processors are you talking about? I mean, if it's got 1,000 processors and enough memory to do that, then you can win by brute force. But I would say, obviously, that's a crazy scenario. Like, when would you have that amount of processors? You're not, a normal computer doesn't have a tremendous amount of processors. So, in the real world, I would think utilizing a bunch of processors to do a bunch of single-threaded tasks or processes is going to be inferior compared to the multi-threaded model. Just because a modern application has so many, components to it. So if you were to break it up by processor, I mean, you'd run out of processors very fast, and then you're running into multitasking where you're now switching, back and forth. So now I'm gonna do a little bit from this process, then do a little bit from that process, do a little bit from back and forth, and try to pretend like I have the ability to do things at the same time. And I think I misspoke there, but the point is, I would rather, and you guys, I don't want to hear what your comments are on that. This is just my thought process. I'd rather have a really fast single processor that is very proficient at multi-threading. So multi-threading capable, fast single processor. I would much rather that than having a whole bunch of processors. But again, the key thing is running single-threaded processes. A lot of people hearing that will think, what are you talking about? The processors can run concurrently. I think I misspoke about that earlier, but the thing with that is, yeah, they can run concurrently, but once again, if every process can only have one thread, if it's single-threaded, then it's you're going to be very limited. You know what? Now I'm starting to really wonder, because say I only have 4 processors, right? Fairly fast process for them. Each of them can only run a single thread at a time, which sounds very inefficient, but those processors, there's 4 of them, and they're very fast. So would I really be able to perceive the switching between, these, because it can't do, like, each processor can only run a single thread. So that means you're doing 4 things at a time, right? So, but my thing is, but these processors are so fast. Because I was saying, what if you need your application needs like 30 things to be done at the same time. You got 4 processors. Each of them is only doing one of the 30 at a time. However, if it's moving fast enough, see, there's a lot of things to consider. I would need to do the math. I would need to consider the how fast this processor can and not just how fast, because I'm trying to think in terms of real world terms. So pick a standard mid-level processor, all right? 4-core processor today, mid-level. How much can that processor accomplish a thread at a time? So I'm not really sure. So I'm curious to know what you guys think. Tell me what you think about what would you choose? Now I want to do some research on this because I'm curious about this. What would you choose? Would you choose a really fast by normal, again, eliminate any like weird, $1 million computer. I'm talking about go to Best Buy, pick it up. The one thing that's weird is the single-threaded application. I don't know who has single-threaded applications today, but would you rather go with a 4-core processor to run a single-threaded application, typical modern application, minus the fact that it's single-threaded? Would you rather that, or would you rather a pretty fast by, again, Best Buy standards, single processor system that supports multi-threading? Which one would you go with? That's tough, man. That's a tough one. I don't know. I don't know the answer to that one. I don't know. I'll tell you right now. I'm about to go look it up. I'm definitely about to go look it up right now. I hope that I don't spend too much time on that, because now that I understand the concepts, fundamentals of multi-threading, now I need to digest the programming side of it. So we're talking a lot in theory, right? A single process can run multiple threads and they run at the same time and they're sharing resources and blah, 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 blah. But in practice, how do I do that? How do I break up my application into threads? How do I put this activity or this, so the YouTube app, right? So the timer logic, right? How do I put that in one thread? The streaming logic, how do I put it in another? Like, what's the mechanism that allows me to do that? Even the sharing of memory, is that something that is sort of automatic, right? I would assume. I don't know. Maybe I don't know. I need to understand that. One thing I forgot to cover also is one of the differences between the multiprocessing and multi-threading, or processes versus threads, is that I can kill a process, but ideally you wouldn't want to kill a thread. I believe it's possible to kill a thread. I can't confirm that, but I do know that's very dangerous and very dirty, because remember, with a multi-threaded application, you're sharing resources, right? So there is the potential of 2 threads trying to occupy or utilize the same space in memory, which obviously that would be a problem. So you have a process that spawns a thread, right? And then you try to kill that thread, which doesn't allow the thread to do adequate cleanup, right? So therein lies a problem where some of the other threads might run into issues because of that thread being killed like that. So it's possible to do it, but it's very dangerous and definitely not recommended. But when you're dealing with processes, obviously, like in Linux, you can kill a process, right? And that is something that is, I don't want to say it can be cleanly done, but it is an acceptable thing to do to kill a process, but not so much killing a thread. Anyway, comment below. Let me know what you think about that question. 4 cores, single threaded application, single core, single processor, multi-threaded application. Which would you choose? All right, let me get back to it. You did click on the like button, right? Right? All right, thanks, guys.